Welcome to my channel. I'm Zhang Xu. Let's look at problem 56 in chapter 19. Wow, this is a big question, right? But we can work it together. It tells us we have a parcel of air, right? A package of air. It moves at a different altitude y. So at different y in the Earth's atmosphere. Now we get the function about the pressure changes with altitude. It equal to negative rho times g. Rho is density, g is acceleration due to gravity. Now we tell you this one, we assume this one is this expansion is adiabatically. This is the keyword. And from this equation, adiabatically equation PV gamma equal to constant. We need to prove these three equations. This is equation 1, equation 2, equation 3. We need to prove these three equations, right? So we make it simple. So it gives you the function, this one and this one. So equation 1, equation 2. You need to prove this one, and this one. So how can we do that? So very beginning, we can say it tells you the relationship between P and V, and it asks you to prove P and T, right? It looks like you can connect P, V, and T. You use ideal gas law. PV equal to NRT or something like that, right? Now you can see this equation is with V, this with T. It looks like you need to replace V with the P, T, R, right? Yes. Therefore, from this equation, you can get the V as NTR over P, right? Now, from this equation, you input the V inside. It looks like this one. P, this term is called V, right? Inside, it is equal to constant, right? Agree? This is PV gamma constant. You replace V with this term. Now you can see you get a function is P and T equal to constant. You need to prove it, right? So we organize it. We write the P outside. So this is P. This is P negative gamma. So we can write it as P1 minus gamma and T times gamma. And then we put the NR gamma outside to the right hand side. So it becomes a constant over NR gamma, right? Now we can say N is the Moore number for this package of air. It's constant. R is constant. Gamma is constant. Therefore, this term is constant, right? Constant over constant equal to constant, right? So this one, bingo, is done. This term, this function is done. Now we look at the next one. From next one, you can see it is still the function between the pressure and temperature, right? But with a differential. So we can consider this function we just get. We can do differential at left-hand side and right-hand side. Do you agree? Because it is differential with y, So we do differential with y at the left-hand side and at right-hand side, this term equal to 0, right? And then we do differential for the P term. So the T gamma is constant equal to this one. And then with the T term, so P1 over gamma, we write it there equal to this one. Right? Now it looks like we just, you can see at this term dp, dy, it just have 1 over gamma. So very straightforward, we can consider we take T gamma and P negative gamma outside, right? See what happens. So we take the T gamma, P negative gamma, it becomes T gamma over P gamma outside. So this term, the first term becomes 1 minus gamma dp, dy. And then this becomes gamma P over T dt, dy equal to 0. Then we can see the function, the term inside this bracket just equal to 0. Agree? Yes, so this one is bingo. Because this is not 0, this is not 0, so this is 0. Therefore, we can write it as 1 minus gamma equal to dp dy plus gamma p over t dt dy. Now we need to prove it there. So easy, because it tells us dp dy equal to negative rho g. So we input the negative rho g inside the third equation. Third equation is proved. So the A part is done, right? Now we look at the B part. The B part is tell you we need to prove this function. dt over dy equal to 1 over gamma mg over k. So we need to prove this part. So how can we do that? So we need to, from this equation, to prove it there. We can see from this equation, we can write the dt and dy at the left hand side, the rest part to the right hand side, right? So we move this term to the right hand side, comes to there, and then just keep dt dy in the left hand side, and then put this part to the right hand side. It looks like this one, right? And then we need to prove this one equal to this one. So you can say 1 over gamma, 1 minus gamma over gamma, this is equal. And then we need to prove rho gt over p equal to mgk, this one. So it looks like, can you connect the p over k? Yes, we can write the ideal gas law, right? PV equal to nkt. Look at there, right? Yes. So it looks like we can write it as T over P, because there we have a T over P. So we write T over P as a V over N times K. K is we needed, but the V we don't, but the K N we don't need it. N is the number of molecules in this package of air. So we can still use it as what? As the mass over the mass over the atomic mass. Agree? Yes, the mass over atomic mass. Therefore, this N just 1 over N just equal to mass over atomic mass. This one. And then we can, the V we don't know, so we divide the V at the upside and downside. So it looks like this one. Now, the mass over the total volume, volumes is called density, right? So in this way, you get T over P equal to M over rho K, right? Now we replace this T over P in there as mg as M over rho K and rho killed. Therefore, we get mg over K. Agree? Now, bingo, we are done for the second part. The third part tell you we know the atomic mass for this air is 29 for air. Acceleration due to gravity is 9.8 meters per second squared. K is a constant, and for the air, it is diatomic ideal gas. The gamma is 7 over 5. You can check our textbook for this part. Ask you to find this constant. This constant, we can say 1 minus gamma over gamma mg over k. So you input this given quantity inside, get the answer there. After that, you can say it tell you the slope, right? You can consider it as slope is negative 9.8 kilometer per centigrade. Right? And it also tell you the attitude changes. Delta y is initial y1 initial position and the final position is given, so you can get delta y at there. And the initial temperature is given, ask you to find the final temperature. Therefore, first one we can find the temperature changes, right? So from this equation we can see the delta T equal to this slope times delta y. Agree? Yes. And this one is given, delta y is given, so you get the temperature changes is 40 centigrade. And this temperature changes use the final temperature minus initial temperature. Therefore, you can get the final temperature is 35 centigrade. Thank you.